Hello and welcome to Math 126 Online. Here's some review for the first several sections, first several days, that is. We're going to try to get through 1.2 and 1.3 today, but they're both pretty long, so we'll see how much you get through. At 9:30, I have to do another online class, so let's get started. Section 1.2, Properties of Exponents and Radicals. Now, really, what we're talking about here is 096 material, so we are reviewing. Some people don't even do the review. I'm doing the review here just to help get our minds in the right place. Maybe been a break since we've had math. So, natural number exponents. If a is a real number, and if n is any natural number, then a to the power of n equals a times a times a times dot 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 times a, where there are n a's being multiplied. The base is the number a in the expression, that's the base, and then the exponent is the number n. So raising a to the nth power is a process of multiplying n factors of a. And the n power of a is a way to express a to the n power. I don't know why my exponents went away there. Okay, so example 1. Evaluate the following. 3 to the 4th power. Well, that is 3 times 3 times 3 times 3. We know 3 times 3 is 9. 3 times 3 is 9, so that's 81. For b, we have negative 4 times negative 4. And that's going to be positive 16. Now, c is a little different. C is saying the negative of 4 squared. So we apply this power before we apply that negative. So it's negative of 4 times 4, which is the negative of 16. And for d, we have the negative of negative 4 cubed times 6 squared. So we're looking at the negative of negative 4 times negative 4 times negative 4 times 6 times 6. So it's the negative of a negative 4 times negative 4 times negative 4 is negative 64 times 36, because 6 times 6 is 36. So 64 times 36, what is that going to be? It's 2304. And the double negative cancels out. And for e, we have x squared times x cubed. That's going to be x to the, well, I should probably not leap ahead, although you should all know this by now. X squared is x times x. X cubed is x times x times x, which is x to the 5th power. Okay. Now, laws of exponents. The product property, if we have a to the n times a to the m, we can add those powers, as we saw in the last example. It's a to the m plus n. 0 as an exponent property, a to the 0 is 1 as long as a is not 0. And the negative integer exponent, if a is not 0, a to the negative n equals 1 over a to the n. So we're going to evaluate the following. Y to the 3rd power over y to the 6th power. That's y to the 3 minus 6 when we're doing the division, which is y to the negative 3. And we typically write that without the negative power. Sometimes we want it without the negative power. We write 1 over y to the 3rd power. For b, we have 12x cubed over 4x cubed. The x cubes will just divide out. 12 divided by 4 is 3. And we end up with just a 3. For c, we have 5 to the 1 times 5 to the negative 5, so we're going to add those powers. 5 to the 1 plus the negative 5 is 5 to the negative 4. Now we can go further with this. This is like 1 over 5 to the 4, which is 1 over 625. And for D, we have 1 over t to the negative 5th. Now, because it's a negative power in the fraction bar, it just comes up, becomes t to the positive 5. Okay. I'm ready to go on to page 2. So you guys can always pause these recordings and get caught up. So quotient property. A to the m over a to the n is a to the m minus n. Power to a power. A to the n to the n is a to the m n. Product to a power. A b to the m is a to the m b to the m. Quotient a over b to the m is a to the m over b to the m. Negative exponent. Negative m over b to the negative n. Now on the notes, if you print out the blank notes, you'll see those symbols. My thing, when I import these, it kind of takes away the negatives for some reason. Sometimes. A to the negative m over b to the negative m is b to the n over a to the m, or a over b to the negative n is b to the n over a to the n. Because I kind of switch because of the negative power. Okay. Simplify the following expression by using the properties of exponents with only positive exponents. Okay, we have 17x to the 4th minus 5x squared plus 2 all to the 0 power. Well, that's just going to be 1. For B, we have x cubed y squared to the negative 1, z to the negative 3, over x squared z to the negative 2. That's going to be x to the negative 3, y to the negative 2, because you give those powers. You multiply 3 times negative 1, 2 times negative 1, times z to the negative 3 minus negative 2, all over x squared. So it's going to be x to the negative 3 minus 2, y to the negative 2, z to the negative 3 plus 2. So it's x to the negative 5, y to the negative 2, and z to the negative 1. So with positive exponents, it's going to be 1 over x to the 5th, y squared, z. So again, if you want to pause that, you can pause it and keep writing stuff down. Or if you print out the post-lesson notes, it's already done. But I think there's value in actually taking notes and working that out. Okay. For C, we have negative 3 x squared y to the negative 2 all to the negative 2 over 27 x to the negative 2 to the 0 times x y to the negative 2. So that's negative 3 gets the power of negative 2. X, so x has the power of 2. 2 times negative 2 is negative 4. Y is the power of negative 2, so negative 2 times negative 2 is positive 4. And 27x negative 2 to the 0 is just 1. xy, negative 2 is x to the negative 2, y to the negative 2. I'm going to go ahead and work this out. Now, because the 3 is, it's a negative 3 to the negative, I take constants and put them where they need to be so I can evaluate them. It helps me to see it better. Then with the variables, I can evaluate them. X to the negative 4 minus negative 2, subtracting the powers. Y to the 4 minus negative 2. So that gives us an x to the negative 2 on top, y to the positive 6 on top, over 9, because negative 3 squared is 9. So y to the 6th over 9x squared. Now, I will slow things down a little bit when we get to the newer material. This is whole chapter 1 and 2 is pretty much review. So, D. We have 5xz to the negative 2 squared, 7x cubed y to the negative 1. So it's going to be 5 squared x squared z to the negative 4, because negative 2 times 2 is negative 4, times 7 to the negative 1, x to the negative 3, y to the negative 1. So 5 squared is 25. We have x to the 2 plus negative 3, y to the negative 1, z to the negative 4, and I'm just going to put that 7 down. 7 to the 1. So we have 25, x to the negative 1, y to the negative 1, z to the negative 4, all over 7. So that's going to be 25 over 7, x, y, z to the 4th. Okay. So if you want to pause it, go ahead and pause it. I'm going to move on now. Scientific notation. Okay, trying to get it centered right. A number is in scientific notation when it is written in the form a times 10 to the n, where a, absolute value of a, is between 1 and 10. It shouldn't be inclusive of the 10. That shouldn't be there. It's strictly less than 10. And n is an integer. If n is a positive integer, the number is large in magnitude. If n is a negative integer, the number is small in magnitude. The number a itself can be either positive or negative, and the sign of a determines the sign of the number as a whole. Okay. So write negative 912 million in scientific notation. So we're going to convert it in scientific notation. Decimal, if it's not showing, it's after the last number. So we're going to move it 1, 2, 3, 4, 5, 6, 7, 8. Negative 9.12 times 10 to the 8. The original number is big. It's a big number, so that's going to be a positive power. Convert 3.2 times 10 to the 7th to standard form. So it's 3.2, and then that's 10 to the 7th. So we're going to move it 7, 1, 2, 3, 4, 5, 6, 7. Put zeros in those empty spots. So it's 3, 2, looks like it's 32 million. Now, because it was a positive power, that's why the decimal went to the right. It makes us a big number. In negative 0.000187, convert to scientific notation. So it's 1, 2, 3, 4 times. Negative 1.87 times 10 to the negative 4. We had to move it 4 times. But since we moved it, we're going into scientific notation, we moved it to the right. That's why it's negative power. The original number is really, really small. So it has a negative power. Okay, so pause that if you want to take more time to write that down. So evaluate each expression. 8 times 10 to the negative 3 times 3 times 10 to the negative 2 over 2 times 10 to the 5th. So what we're looking at is 8 times 3 over 2. That part we'll evaluate. And then we have 10 to the negative 3 times 10 to the negative 2 over 10 to the 5th power. So 8 divided by 2 is 4. 4 times 3 is 12 times 10 to the Negative 3 minus 2, so negative 3 plus minus 2 minus 5. 12 times 10 to the negative 10. That's not in scientific notation, though, because the 12 is bigger than 10. So think of that as 1.2 times 10 to the 1. That's our 12. Times 10 to the negative 10. That's just 10 to the negative 10. So it's 1.2 times 10 to the negative 9. Oh, hi, Aspen.
Hello.
Just going through lesson 1.2 here. It's a review. All of chapter 1 and 2 are pretty much reviews of the 096 material. So you've probably seen this before. I've been talking to myself for the last 20 minutes or so. So, are you ready to go on?
Yeah.
Okay. Okay, let's do B. 3.2 times 10 to the 7th times 5 times 10 to the negative 4th times 2 times 10 to the negative 10. So we're going to multiply those first parts. 3.2 times 5 times 2 times, and then we have 10 to the 7th times 10 to the negative 4th times 10 to the negative 10th. So I'm kind of grouping them together, the first parts and then the 10 parts. So 3.2 times 5 times 2, that's 32. We have 10 to the, now we have 7 plus negative 4 plus negative 10, because we add those powers since they're the same base. So that's going to be negative 7. Now, is that answer in scientific notation?
No.
No, you're right. That's 32. So we have to make that, that's like 3.2 times 10 to the 1. So that's how we'd write 32 in scientific notation. We still have that times 10 to the negative 7. 3.2 times 10 to the negative 6 then. Any questions about that?
No, I think I got it.
Good. Okay, nth roots and radical notation. And we're covering, I got to say, in this one section, I feel like we're covering the majority of 096, but I mean, we still have, I think we'll go through 1.8. It's just a lot in this one section. It's what, 7 pages. Okay. Case 1. N is an nth root. N is an even natural number. If A is a non-negative real number, and if N is an even natural number, the nth root of A is a non-negative real number B with a property that B to the N equals A. That is, nth root of A is B, same thing as A equals B to the N. In this case, note that the nth root of A to the N equals A, and the nth root of A to the N, the other way is still A. Case 2, and I think that there's actually, I think that's supposed to be the absolute value of A. Here. Because being the an even integer, so like if you had negative 2, well, let me not say negative 2. How about negative 3 squared, the quantity squared, you can have positive 9. Take the square root. Let's do that. Negative 3 squared equals 9. The square root of 9 equals 3. So that the square root of negative 3 squared is the absolute value of negative 3, which is 3. That is, when you have an even power, it makes the negative go away. Okay, in the second case, n is an odd natural number. If A is any real number and n is an odd natural number, the nth root of A is a real number b whose sign will be the same as the sign of a, with the property that b to the n equals a. And so you have the same pretty much idea here, but now if we're looking at negative 2 cubed is negative 8, the cube root of negative 8 is negative 2. So the negative is preserved in this case, where in the previous case it goes away. The expression the nth root of a expresses the nth root of a in radical notation. The natural number n is called the index, a is the radicand, and that square root symbol is called the radical sign. By convention, square root of 2 is usually written as just the square root, or the second root. The second root is usually just written as square root. The point on that is, if you don't see an index of the radical, it's a 2. Okay, so what is the cube root of 27? What do you think, Aspen? What's the cube root of 27? You can think of that as the cube root of negative 3 cubed, so it's just negative 3. What about the sixth root of negative 64?
It'd be positive because 6 is an even number.
It would if we were raising to the power of 6, but we're not. We're just trying to take the sixth root, which is an even index, and we're not allowed to do that. And so this is not a real number.
Okay.
Now, if we're doing the sixth root of negative 64 to the sixth power, then it would be 64. But here we're just saying the sixth root of something negative, and you cannot take the root of an even indexed root of a negative. So that's the problem here. You could do it if it was odd, like your cube root. Hang on a second. Okay. Someone's here for my next class. Okay, the fourth root of 81. What's the fourth root of 81? Well, that's like the fourth root of 3 to the fourth power. So it's what? What would that be, Aspen? The fourth root of 3 to the fourth power. It's going to be 3. So we could do this one because it was the fourth root of a positive number. We couldn't do the previous because it was the sixth root of a negative number. Okay. Let's go on to page 5. Simplified radical form. The radicand contains no factor with an exponent greater than or equal to the index. That'd be in simplified form. So it wouldn't be like, you couldn't have a square root of something that's like x cubed inside, because the power inside is bigger than the index. The radicand contains no fractions. The denominator, if there is one, contains no radical. That's really important. The denominator contains no radical. And the greatest common factor of the index and any exponent occurring in the radicand is 1. That is, the index and any exponent in the radicand have no common factor other than 1. So we'll do. So the nth root of a to the n equals a if n is odd. The nth root of a to the n equals absolute value of a if n is even. That's what I was talking about earlier. Nth root of ab is nth root of a times nth root of b. The nth root of a over b is nth root of a over nth root of b. And the mth root of the nth root of a equals m times n, the m times nth root of a. Whew, that's a lot. So let's try some simplification here. The cube root of negative 8, x to the 6th, y to the 9th. So I'm doing cube root here. So here's kind of the rule. Let me rewrite that negative 8, and hopefully this will be clearer. That's negative 2 cubed. What we can do basically is this. Divide the powers. This is negative 2 to the 3rd power. 3 divided by 3 is what? It's 1. We have x to the 6th. 6 divided by 3 is x squared. Y to the 9th. 9 divided by 3 is y to the 3rd. So that one worked out well because there were no remainders. So it's negative 2x squared y cubed. Now for the next one, we have the square root of 2x to the 6th y. Well, this is like having an index of 2. I'm going to leave that normal so people don't think I've changed it. It's like having a square root of 2, 2x to the 6th y. Well, 2 has no power other than 1, and y has no power other than 1. So we can divide the 6. 6 divided by 2 is 3. Square root of 2y. Power of 6 by index of 2. Divide the power by index of radical. There we go. So let's try this next one. It says to split them up, we have the cube root of a cubed b to the 12th over the cube root of 27c to the 6th. The cube root of a cubed, well, 3 divided by 3 is 1. 12 divided by 3 is 4. 27, the cube root of 27, 3, and cube root of c to the 6th, well, 6 divided by 3 is 2. Okay, I've got 2 more pages to go through in this section. Probably not going to get the next one today. Definitely not going to get the next one today. Okay. Moving on down the line. Now, rationalizing the denominator. As we said earlier, you cannot have radicals in the denominator. So when we have a radical in the denominator, we need to multiply by something. So the index and the power are the same. So we can bring it out. That's the key. We're missing some symbols here. So we multiply like the nth root of a to the m by the nth root of a to the n minus m. So what we have is a to the m times a to the n minus m, excuse me. Is a to the m plus n minus m, which is a to the n. That's the whole idea. And remember, when we multiply these, you have to multiply by the same thing on top and bottom. Okay. And for case 2, you have two terms. You have to multiply by the conjugate. So if you have a plus, well, here we have square root of a plus b, you have to multiply by square root of a minus b. So you have to multiply that out, a minus b squared. Okay, so let's simplify these. Okay, it says to take that and make it a cube root of 4x squared. Can't do anything with that numerator. The cube root of 3y to the 4th. Now, we can do stuff with this denominator. We, in fact, have to do stuff with the denominator because we cannot leave a radical in the denominator. 3 is going to stay, but y to the 4th, that'll bring a y out. Then we have the cube root of 3y to the 1. Now, the 3 has to have a power of 3 to come out. The y has to have a power of 3 to come out. So I'm going to multiply by the cube root of 3 squared y squared over the cube root of 3 squared y squared. So on the numerator, we're going to multiply through, which is going to be the cube root of 4x squared times 3 squared y squared. In the denominator, we still have that y sitting out there. And we're going to have the cube root of 3y times 3 squared y squared. I'm doing this in a lot of steps on purpose, not to drive you crazy. So it's 4x squared times 9y squared. Down below, we have the y out front. 3 times 3 squared is 3 cubed. Hey, look, their powers match. That can come out now. Y times y squared is y cubed. Hey, the power matches the index. It can come out now. Not a coincidence. So it's the cube root of 4x squared. No. Back up, Jeff. 4 times 9 is 36. X squared, y squared. Over y times 3 times y, because the cube root of 3 cubed is 3. The cube root of y cubed is y. So it's a cube root of 36 x squared y squared all over 3y squared. And that's it. No radical in the denominator. That was the key. That one took more space than I wanted it to. Any questions before we do the next one? Okay, let's go ahead and multiply by the conjugate here. We have square root of 2 minus square root of 5, so we'll multiply by square root of 2 plus the square root of. So multiply through the numerator. 3 times square root of 2 is 3 square roots of 2. 3 times square root of 5 is 3 square roots of 5. Now down below, what we have is that situation going on of the a plus b times a minus b. That's a squared minus b squared. So it's going to be the square root of 2 squared minus square root of 5 squared. So we're going to have 3, I probably should have multiplied that through because I see what's going to happen here. 3 times the square root of 2 plus 3 times the square root of 5 over 2 minus 5. So 3 times the square root of 2 plus 3 times the square root of 5 over negative 3. 3 times square root of 2 plus square root of 5 over negative 3, and they cancel. These are negative 1. Negative square root of 2 minus square root of 5. This last one, conjugate, is going to be the square root of x plus the square root of y. So the numerator what we have is the case a plus b times a plus b, which is a squared plus 2ab plus b squared. So it's going to be x, which is maybe say square root of x squared, plus 2 times square root of x times square root of y plus square root of y squared, all over square root of x squared minus square root of y squared. So it's x plus 2 times the square root of xy plus y squared. No, plus just y, Jeff. All over x minus y. And that's it. No, we cannot cancel the x's and we cannot cancel the y's. People try to do that. Okay, any questions before we go on to the last page? Okay, page 7. Now, combine the radical expressions if possible. You can only combine them if they're like radicals. That means the same index, the same stuff underneath. So we have the square root of 27. That's not cubed, it's the square root of 27. So I'd split that up to become 9 times 3 times x times y squared minus 4 times the square root of 3 times x times y squared. So in the first one, square root of 9 can come out. That's just 3. Square root of y squared is y. We have a 3x inside. The second one, there's a 4 out front. Square root of y squared is y. 3x stays inside. So we have is a 3y times the square root of 3x minus 4y times the square root of 3x. 3y minus 4y is just negative y times the square root of 3x. Okay, let's take on the next one. I think it to be technically correct, I was supposed to say the absolute value of y there and there. So it's negative absolute value of y times the square root of 3x. Okay, for the next one, we have the absolute value of x times the square root of 8x y squared z cubed minus absolute value of yz times the square root of 18x cubed z. So I'm going to break up that 8. It becomes 4 times 2 times x times y squared times z cubed minus absolute value of yz square root of 9 times 2 times x squared times x times z. So we end up with, in the first case, absolute value of x, y, z, and the square root of 4 is just 2. That can go out front there. Times the square root of 2x. What's z cubed? Oops, that's z. So it's still inside. Minus, the 3 can come out front, absolute value of x, y, z times the square root of 2xz. So these are like radicals. We have the same index. They're both square roots, and they both have the same terms under the radical. So 2 times the absolute value of x, y, z times the square root of 2xz minus 3 times the absolute value of x, y, z times the square root of 2xz. It's going to be negative absolute value of x, y, z times the square root of 2xz. Okay. Almost done here. So rational number exponents. The meaning of a to the 1 over n, that's, I don't really have a place to write that. That's a to the 1 over n is the nth root of a. The meaning of a to the m over n is going to be the nth root of a to the m or the nth root of a, all that to the m. They mean the same thing. A to the negative m over n is 1 over a to the m over n. So 81 to the power 3/4 is going to be the 4th root of 81, and then we're going to cube it. That's 3. 4th root of 81 is 3. 3 to the 3rd power is 9. No, 27. Now, you could have put that in the calculator as a power. That would have been fine. Now, for the next one, this is where it's really useful to go to those powers. 7th root of n to the 9th. Well, I guess we don't need to on this one. 7th root of n to the 5th, I will. So it's n to the 9/7 times n to the 5/7, n to the 9/7 plus 5/7 is n to the 14/7, which is going to be n to the 2 power. And then the square root of 5, 4th root of 5, that's going to be 5 to the 1/2 times 5 to the 1/4. It's 5 to the 1/2 plus 1/4, or 5 to the 2/4 plus 1/4, 5 to the 3/4, which is the 4th root of 5 cubed, or you can write that as the 4th root of 125. They're both acceptable answers. We'll stop there today. We'll pick up 1.3 on Thursday and probably do 1.4 on Friday. So, I don't know if you can still hear me, Aspen. We're going to stop with that then. So I'm going to end this archive. When I do the end of the archive, if there are no questions, well, I'll count down. And if you count down from 5, if you have a question, stop me. So I do. In the archive in 5, 4, 3, 2, 1.